Most AI systems you see today are wasting money, not because of bad models, but because of bad memory. Every time your product asks GPT, Claude, or Gemini the same question again, you are paying full price for work your system already knows how to do. It's like retraining your employees every morning before they start work. I'm Swarnendu. I help SaaS and AI teams scale without burning through compute bills. If your AI bill keeps doubling, this one strategy, caching, might cut it nearly in half. Subscribe for more engineering frameworks that save costs and improve system performance. Caching isn't new, but in AI, it's finally quantifiable. Across several published studies and production systems, caching has reduced inference cost by 40% to 90% depending on workload. Ionio.ai, for instance, shared that they saved around 50% of OpenAI API costs with prompt caching and model routing while also improving latency by 30%. And AWS Bedrock demonstrated that prompt caching reduced both cost and latency by up to 90% and 85% respectively. But here is the real reason why it matters for SaaS. Over 60% of user queries in production AI systems are variations of previous prompts. Caching reuses those computations, keeping both token usage and GPU time. So let's talk about how teams are actually implementing it. Strategy number one, prompt caching, reuse what's already answered. Prompt caching is the simplest layer. You store input output pairs so the next time the same or similar prompt appears, you serve the cached result instead of calling the model. How to do it effectively? First, normalize prompts before comparison. Clean up variables, spaces, punctuation. So summarize this report for Q1 and summarize this report for Q1 with a full stop. Do not miss as duplicates. Second, semantic matching, not just exact text match. Companies like Perplexity and Langchain Semantic Cache use embeddings like OpenAI's text embedding 3 small to find similar prompts. If cosine similarity is above 0.95, reuse the previous output. Third, add TTL, that is time to live, to prevent stale responses. Ionio uses 24-hour TTL for dynamic data, 7 days for static FAQs, balancing freshness with efficiency. And what's the impact? In practice, most teams achieve 40 to 60% cache hit rate in chat or FAQ like workloads. This translates directly to a 40 to 60% cost reduction. Strategy number two, embedding and feature caching, the RAG multiplier. If you're using RAG, that is retrieval augmented generation, caching embeddings is where real savings kick in. Generating embeddings for every user query is costly. Each embedding call can cost up to 20 to 30% of your LLM cost. So what leading teams are doing about it? First, Shopify's engineering blog mentioned caching embeddings for product descriptions to speed up semantic search. Notion AI caches document embeddings per section, recomputing only when the user edits that section. Tetrate.io documented that reusing pre-computed feature maps improved throughput by 2 times. How you can do it? Use a fast key values tool like Redis or DuckDB to store embeddings locally. Next, maintain a hash like MD5 or SHA of text chunk as your cache key. Next, when a query comes in, compute its hash and compare only embed if not found. And then track hit rate and total tokens saved for visibility. Embedding caching often costs 20 to 30% of your RAG pipeline cost and scales even better as data grows. Strategy number 3, model routing plus caching. Use small models first. One of the most practical cost levers is model multiplexing. Instead of always calling GPT-4, route simple tasks to a smaller models and cache their results. Here's a case. In the 2023 paper on optimal caching and model multiplexing for large model inference, researchers Zhu et al. Achieved up 50 times cost improvement by combining caching with selective model uses. So how it works in production? Add a routing layer that categorizes requests, factual lookup, creative generation, summarization, etc. And then route these low complexity queries like short factual answers to cheaper models such as GPT 3.5 or Claude, for instance, and then cache their results for future reuse. Finally, only call the expensive model for complex reasoning tasks or new topics. This hybrid routing and caching design reduces compute load dramatically. Ionio's proxy layer implementation is a good public example of this. Strategy number 4, plan template caching in agentic systems. Agent workflows like planning, reasoning, decision trees often repeat the same reasoning steps. A recent ArcZip paper on agentic plan caching showed that caching plan templates reduced overall cost by 46% on average while retaining 96% of output accuracy. How to apply this? Cache the structured plan or chain of thought templates, not the final output. When a similar task appears, reduce the cached plan and only rerun the variable states. For example, in an AI task manager, summarization with extract action items and assign deadlines can be a cached plan. So next time, just plug in the new meeting notes. This forms of caching doesn't just save tokens, it reduces agent latency and planning overhead. Strategy number 5, cache architecture. Build it like a system, not a patch. If you want to go beyond proof of concept, caching must sit as part of your AI platform architecture, not as a middleware afterthought. Here's the architecture most teams follow. First, the inference proxy layer. Tools like LLM proxy or custom gateways handle cache lookups, semantic match, and fallback to model. They log every request and hit or miss for analytics. Second, a multi-tier cache. Tier 1 can be an in-memory that is ready for recent request. Tier number 2 can be persistent like Postgres or Elastic Cache for long-term reuse. And Tier 3 can be optional shared cache across tenants for common tasks. Then you can have cache governance, define TTLs, versioning by models, and tenant level isolation. And then there are metrics and dashboards. You need to track cache hit rate, cost saved, average latency reduction, and token savings per day. Without metrics, caching becomes just guesswork. This structure is already visible in production at firms like Perplexity, Anthropic, and Hugging Face inference endpoints, where caching is now part of their serving infrastructure. Strategy number 6, measure return of investment and tune hit rate. Caching is only good as your measurement. So what do you need to measure? First, cache hit rate. Second, cost per request, that is cached versus non-cached. Next, latency difference. And fourth, memory footprint. And then you can run control experiments like increase semantic similarity threshold from 0.9 to 0.95 and observe savings versus accuracy drift. This is exactly what LLM proxy research focused on, finding the sweet spot between cost and quality. For large SaaS deployments, a 50% hit rate typically translates to a 40 to 50% real cost reduction, as observed in Ionio's reports and the agentic plan caching paper. So caching isn't just a trick, it's a foundation of efficient AI infrastructure. It's what turns AI from a cost center into a scalable capability. Most teams will save at least 40% of time and cost by implementing prompt and embedding caching. Add model routing and plan caching and you will reach 60 to 7% savings without touching the model itself. So before negotiating your next API contract, audit your own memory first. Because in AI systems, the smartest models aren't always the ones that think more. They are the ones that remembers better. Subscribe if you want more engineering first frameworks that help you build AI products that actually scale profitably. Thank you so much for watching.